Hello, this is Pat Obi, Purdue University, Northwest. Welcome to my second of 3 presentations on logistic regression model. In this presentation, I'm going to show how to obtain logit regression estimates using EViews. The lead story for this presentation is shown here, and you can pause this video to read it, but I'm going to summarize it real quick. Now, this is a 2 independent variable model in which we seek to estimate the likelihood of loan approval given the applicant's down payment x1 and income to loan ratio x2. And here's the data set. The first applicant's down payment, as you can see, is 16.35% and income to loan ratio is 49.94%. This applicant's loan application was successful, hence we assign the value of 1 to y. Now, in similar fashion, this last applicant's down payment is only 17.85, and income to loan ratio is only 26.86%. And as you can see, this loan application wasn't successful, and that's why y is equal to 0. No pun intended there. All right, the EViews command is summarized here. So let's go to EViews real quick. And let's get rid of what we've already done before so you can know exactly what's going on. So we can look at the data sets if you want to as a group. If you highlight all of them, right click and open as a group. And that's what you saw just a quick second ago. In any event, you don't really have to have this open. If you don't want to, you can X out of them. So let's go ahead and execute the command. So we want to go to quick, and then want to scroll down to estimate equation, and then we want to type out our equation while cursor is blinking there. We type y space c for constant. dp is the first variable here, down payment, and space il is what we call income to loan ratio. And that's really it. And then for method, right here for method, click down arrow and let's go to binary choice. Click on it and check logit and click OK. And that's our output. And these are the coefficients that you see there for down payment and income to loan ratio. And if you carry this out, you can see the p-values corresponding to those two coefficients right there. So let's go back to PowerPoint, which makes it much clearer. So here's the output again, copy it over to PowerPoint. And here's the estimated logistic model right here with the values substituted in. Now, however, note that the estimated logit model is the log of odds ratio. To find the estimated probability, we define the logit function for the 2 independent variables and then substitute the estimated values of the coefficients as shown right here. And so this is the predicted loan approval probability, which can be calculated for different levels of down payment and income to loan ratio. But the question I pose here is, how do we interpret the coefficients B1 and B2 that you see there? Now consider the value of B1, which is 0.1349. The coefficient of down payment right there, as you see. Now, in the traditional fashion of interpreting regression coefficients, we would say that for every 1 unit increase in DP, down payment, the dependent variable here increases by about 0.135 units for a defined level of income to loan ratio x2. Now though, remember that this dependent variable here is the log of odds ratio. It isn't the probability, which is what we're gunning for. And this is why, as I note here, we must be careful to only interpret the sign and not the magnitude of the coefficients when we run logit regression model. So then, where do we go from here? Well, again, consider the estimated logit model. We note here that the coefficients are all positive. And so the sign of the coefficients, positive in this case, indicates that they're going to have positive influence on Y, which is the likelihood of loan approval. Specifically, with higher down payments, I write here, a customer's likelihood of loan approval increases. We can say that. We can also say as well that a higher income to loan ratio, this variable here, would increase the odds of loan approval. And that's as far as we go, as far as telling a story about the value of these coefficients right here. In the third and final presentation, I'm going to provide an extended interpretation of the odds ratio at different levels of the independent variable. Thank you.